Okay, so let's go ahead and let's look at problem number 2, which is a real-world application problem. They said the function rule W equals 146C plus 30,000 represents the total weight W in pounds of a concrete mixer truck that carries C cubic feet of concrete. If the capacity of the truck is about 200 feet squared, what is the reasonable graph of the function rule? So all we're going to do is basically what we just did. We're going to plug in this information. Say 146 times 0 plus 30,000. Well, that gets us the 30,000 because anything times 0 is 0. So we have the coordinate 0, 30,000. I kind of wrote that, gave a little bit of room there, so I need to make that a little bigger. But we take 146 times 50 plus 30,000, and this one we get, so work that out, we get 37,300. So we write that down. We had 50 comma 37,300, and then we take 146, we plug in 100 for the C, which in this case is C, and plus the 30,000. So 100 times 146, and then plus the 30,000, and in this case we get 44,600. So we had 144,600, and we just keep doing this as we go through, and it's just a plug and chug type method, as you'll hear me refer to it as. And this gives us 51,900. So we use 150 and we get 51,900. And then the last one we got 200 and 146 that we plug in there. We go ahead and erase that. We get 146 and then we plug in 200 for the C plus the 30,000. This 0. Which in this case gives us 59,200. So 200 produces 59,200. Okay, so now we're just going to go ahead and go over here and plot. So we said, let's call this 50. So this is going to be our C down here, because that's our input. This is really always going to be your input line. Okay, that x-axis is always your input. We had 100, 150, and 200, and then up here what we're going to do is we'll count by 10,000, so it's label though 20,000, 30,000, 40,000, 50, and then 60. Okay, so if we plugged in 0, we got 30,000, so that's our first coordinate right there. 0, 30,000. 50 we plugged in and we got 37,3, so that's up here. 100 we plugged in, we got 44, so that was up here. 150 we got 51, which was like up in here, and then 200 we got 59, which is right in there. Okay, that's off a little bit. Again, I'm hand drawing these, so you have to keep that in mind. So there's what we should have, and really, let me go ahead and fix that because I didn't leave a whole lot of room here. This was 50 and 60 was probably up in there, which means we're right in there. So that would fit on that line. But you'll notice in this one that we did not go in the negatives because we're talking about carrying concrete. You can't have negative concrete, so you'll notice that I didn't extend this line past where we were, and we only use this first quadrant, okay, quadrant 1. Because we weren't negative. You can't have a negative amount of concrete. So therefore, in context of real world problems, you got to keep that in mind, that a lot of times negatives won't come into play. Okay, so we're going to look at one more problem, then I'll have one more due on your own. We're going to look at nonlinear. So the last couple we looked at were making lines. So now what we're going to get into is what happens if we don't have a line. We have just a nonlinear, which is going to be curves or different things like that. So again, I'm just going to pick some points here. So I'm going to pick like -1, 0, 1, 2, and 3. So I'm just picking values here. And then what I'm going to do is I'm going to plug those in and evaluate those out. So I'm taking -1, plugging in for the x. Absolute value, that's what these are. Absolute value of -1 is 1. 1 minus 4 is 3. So I know I have -1, 3, -3. If I plug in 0, absolute value of 0 is still 0. Minus 4 gives me 0, -4. If I plug in 1, the absolute value of 1 is 1. Subtract 4, I get -3 again. If I plug in 2, the absolute value of 2 is 2. Minus 4 gives me -2, so I get 2, -2. And then if I plug in 3, absolute value of 3 is 3, but then I get -1. Okay, so as I look at this problem, I'm just going to plot these coordinates. So really you don't need to know what this looks like right now. You really just need to be able to plug values in, chug them out, and get your coordinates. So I go -1, 1, 2, 3 down. There's my first coordinate. 0, I go 4 down. There's my second coordinate. 1, I go 3 down. So it's always x going left and right first, and then up and down. So 2, so I go 1, 2, and then down 2. And then I go 1, 2, 3, and down 1. So those are coordinates I picked. Now if I pick more coordinates this way, I'm going to follow the same path going up. So what this one looks like is it goes like this, and then it goes back up this way, and it makes a V. That's what absolute values will look like. And we'll look really, this becomes really something we look at a lot later in the year, and then we'll also, in Algebra 2, you'll really hit these and what they look like. Okay, but that's what you do nonlinear. So this one's not, it's not a straight line, it's actually a V. There's a sharp turn right there, and that's how you make that graph. You just by picking points, you pick x values, you evaluate them out to get your y values, and you make coordinates, and then you plot those and connect the dots. Okay, so here's one more problem. I want you to go ahead and evaluate that out, and this should be a squared, but it was not working for me. But I want you to go ahead and work this problem out on your own. When you come in tomorrow, we'll look at that together. Okay, so we'll stop there. That's all we're going to do for today. We'll talk more in class tomorrow as we go over how to graph functions. This is a very big concept because it's something you're going to be using for a long time throughout your high school career and any college course that you take.